Hello everyone, my name is Sanjeev and today we're going to be looking at our SAT math problem solving and data analysis. More specifically, we're going to be looking at the scale ratios, rates, proportional relationships, and units. And as always, we're looking at a set of 5 difficult questions. So let's dive into the first question. Our first question is saying a sample of oak has density of 807 kilograms per cubic meter. The sample is in the shape of a cube where each edge has a length of 0.9 meters. To the nearest whole number, what is the mass in kilograms of the sample? Now, there are two ways to solve this problem, through dimensional analysis and through your formula. And in reality, they're kind of both the same thing. It's just a way of how you're looking at it. So I'll just use the formula method first and then tell you what's the difference between dimensional analysis and our formula. So our formula is density is equal to mass over volume, right? So we know our density is 807, and we don't know what mass is. That's what we're trying to find. So x or volume. So now what is volume? Well, you know the sample's in the shape of a cube, where each length has an edge of 0.9 meters. We know that volume is equal to s to the third, where s is the side length, in a cube. And we know that in this case, s is 0.9 since it says the edge is 0.9 meters. And of course, you have a calculator in your test. So figuring this out, you get V is equal to 0.729 meters cubed. And wait, I also put S is equal to 0.9 meters. There's a reason for this, and that has to do with the dimensional analysis portion. And now what we just do is plug and chug. We get 807 is equal to x over 0.729, and multiplying both sides by x, you get x is equal to 588.303. And of course, we need to actually read the problem, and it says to the nearest whole number, what is the mass? So in terms of whole numbers, we'd remove this decimal portion and put in our unit of kilogram. Okay. And remember, always read the question, because in this situation, it says to the nearest whole number. And you might be asking, isn't this, a multiple choice question? Well, even in multiple choice, there might be an option where you have a decimal point afterwards. And there are still quite a few questions in the SAT where you get, free response type questions. So if you do not prepare yourself to read the question, you might get the answer wrong. So always make sure to read the question. Now, looking at it from a dimensional analysis perspective, we have density, which is in kilograms per cubic meter, right? So kilograms per cubic meter, and we have meters, which is our edge length. So what we need is, we see a term of m to the third here. So we also need this one to be m to the third. How do we get m to the third? Well, we need to cube it, of course. So that's where we take 0.9 to the third to find the volume. And we know what kilogram per meters cubed is, which is our 807, right? And then using that, and we know that our meters cubed is 7.729, we can figure out what our kilogram is by just multiplying by meters cubed to find the kilograms. Does that kind of make sense? The dimensional analysis might be a bit complicated, because you use it more often in chemistry instead. Of course, our answer is 588. And let's move on to the next question. Our next question states, in a scale model of an office building, a length of 1 inch is equivalent to a length of 17 over 3 feet in the actual office building. If a length in the actual office building measures x feet, which expression represents the corresponding length in inches in the model in terms of x? Well, that sounds really confusing, but what we can do is break this problem part by part. It says, the first part of the question is saying 1 inch is equivalent to 17 over 3. Well, this is 17 over 3 feet. This is a ratio, and ratios can be represented using this symbol. Okay, and what we're trying to figure out is, if we have x feet in the actual building and y inches in the model, what is y, right? how are we going to solve this problem? Well, first we need to figure out, what is in 1 feet, how many inches is it in scale proportionally? So we need to figure out what z is per se. So what we're going to be doing is multiplying both sides by 3 over 17, and we get 3 over 17 inches in 1 feet. Now, how can we do this? Because even though this is a ratio, ratios are inherently proportional. That means that if we're multiplying this by 3 over 17, this side also needs to be multiplied by 3 over 17 in order to maintain that same proportion, right? And we know now that this expression, our third expression right here is just x times our second expression right here. So we just multiply both sides by x, and you get 3x over 17 inches will be equal to x feet. And that will be our answer, which is option choice C. And now moving on to our next question, where it is the speed of a vehicle is increasing at a rate of 7.3 meters per second squared. What is the rate in meters per minute squared? In miles per minute squared, rounded to the nearest tenth. Okay, now look at this. We have units of meters per second squared, and we turn it to miles per minute squared, right? So how are we going to do this? We're actually going to use dimensional analysis for this. We were talking a bit earlier about this. However, we're going to look at this in a bit more detail. Okay, if we have a value of 7.3 meters per second squared. Let me make this, okay. Okay, so say we have a length of sorry guys. Okay, sorry for those technical interruptions, but say we have 7.3. Okay, never mind. That was not. Okay, that is somewhat better, I guess. Okay, so say we have a rate of 7.3. Well, we do have a rate of 7.3 meters. Okay, and we are gonna put per second squared or second squared in our denominator. Okay, so imagine as if this line is separating our numerator from our denominator. Okay, we're starting out with 7.3 meters, and we have second squared in our denominator. We're trying to find out miles per minute, right? So we know that in 1 mile, there's 1,609 meters, right? So 1,609 meters in 1 mile. 1 mile. Like this. And then what we know is that in 1 second, right? In 60 seconds is 1 minute. 60 seconds in 1 minute. However, we have a problem, right? Because we have seconds squared, not seconds. So to get seconds squared, what we would need to do is multiply it times 60 again. So 60 times 60 seconds squared and 1 minute squared. And then this would be equal to 3600 seconds squared per minute squared. And then what we can do is cancel out all these terms, right? So meters, seconds squared over seconds squared. And we're just left with miles per minute squared. Now we can multiply our numerators and divide them by our denominators. And that's what we have a calculator for again. So 7.3 times 3600 divided by 1609. And we're left with 16.3. And that's answer choice B. And that's how you do dimensional analysis. It's kind of the method I used in our first problem as well for part of our thing, and we use this mostly in chemistry. Now moving on to our fourth question. Jeremy deposited X dollars in his investment account on January 1st, 2001. The amount of money in his account doubled each year until Jeremy had $480 in his investment account on January 1st, 2005. What is the value of X? Okay, well, let's look at this way. He inputted X dollars at 2001, right? And then it doubles each year. So it'll be 2x at 2002. And then we're doubling this again, so it'll be 4x at 2003. And then 8x at 2004. And then 2005 will be 16x, right? And we know that 16x is equal to 480. Now, dividing both sides by 16, we get x is equal to 30. So he inputted in $30. And that's how you solve this problem. Moving on to our last problem. It says if 4a over b is equal to 6.7 and a over bn is equal to 26.8, what is the value of n? Okay, how are we going to approach this? So we know what 4a over b is. It's equal to 6.7. So then what is a over b? Well, what we're doing is dividing by 4 on both sides. So we need to do 6.7 divided by 4. And we are getting 1.675. Now, if we look here, we have a over b times a over bn, right? So what we're doing is multiplying the denominator by a factor of n. So it will be a over b, a over b times 1 over n will be equal to 26.8. We know that a over b is equal to 1.675. So 1.675 times 1 over n will be equal to 26.8. And multiplying both sides by n, we are getting 1.675 will be equal to 26.8n. Dividing both sides by 26.8, and we get a value of n is equal to 0.0625. And that's how we would solve this problem. That's it for today, and thank you all. Have a great day.